accident was a result of a test being performed with safety features disabled. The reactor achieved prompt criticality, which caused a steam explosion and fire that released significant levels of contamination from the destroyed core. Note, these were not explosions of a nuclear bomb, but rather more like explosions of an overheated furnace or boiler. The firemen first attempted to pump water into the reactor. That was unsuccessful. From helicopters, they dropped 5,000 tons of boron, sand, clay, lead, and dolomite onto reactor number 4 so they could smother and extinguish the fires. On April 26, 1986 at 1:23 a.m., Unit 4 experienced a severe reactivity excursion accompanied with a pressure surge and fire that destroyed the reactor and breached the surrounding building. Chernobyl had the right to obtain a license to operate a nuclear plant, but they failed the responsibility to operate it safely. 2 Chernobyl plant workers died the night of the accident, and 28 people died within a few weeks of the accident. The day of the accident, April 26, 1986. Chernobyl's nuclear plant operators were running tests to see how long the turbine generator would continue to supply power near rated voltage for essential equipment. The generator coasted down. At 1:05 p.m., turbine generator number 7 was shut down with the reactor at 50% power. At 2 p.m., the emergency core cooling system was defeated in accordance with the test program. This was done to ensure that an inadvertent actuation would not interfere with the test. In addition, the load dispatcher required a demand for the power from Unit 4 and requested the test to be delayed. At 11:10 p.m., according to the test procedure, reactor power was reduced to a power level between 700 to 1,000 megawatts thermal. During the test, the power level fell below the level recommended by the procedure. As a result, the operators raised power by pulling control rods. That was not in compliance with the procedure. At 1:03 a.m., they added additional cooling water outside of what was allowed by procedure. Additional water flow required withdrawal of control rods to maintain power level. Operators experienced difficulty controlling steam pressure and water level. At this point, emergency protection equipment was bypassed. At 1:23 a.m., conditions were plummeting. Coast down of cooling water pumps caused more steam flow, resulting in a rapid power rise. Operators attempted to insert control rods but were unsuccessful. A loud noise was heard from the reactor. The power peaked at 100 times its normal level. The significant release of energy lifted the 1,000-ton reactor cover plate off the reactor. Because the graphite inside the reactor had ignited, radioactive dust spewed out with the smoke traveling long distances. The Chernobyl accident, can it happen here? To understand the differences between U.S. plants and Chernobyl, we must understand how a nuclear plant operates. Nuclear plants use uranium-235. When a U-235 nucleus is struck by a neutron, it splits into 2 nuclei called the fission process. This fission reaction releases heat 50 million times as much heat released in a coal-burning process. slow down neutrons, a lightweight nuclei that the neutrons can transfer energy to must be introduced. Materials introduced for this purpose are called moderators. Another possible moderator is ordinary water as used in U.S. plants. However, a chain reaction cannot be achieved from a mixture of natural uranium and water. If natural uranium is enriched up to 3% from its normal 0.7%, then water becomes a good moderator. One problem with operating a reactor is controlling the rate at which the chain reaction proceeds, which determines the rate in which heat is produced. Inserting control rods made of boron that absorbs neutrons slows down the reaction. By withdrawing them, speeds up the chain reaction. Note that Chernobyl lost control of their control blades during the accident. In U.S. plants, the reactor vessel is filled with water that is rapidly pumped through to be transferred into steam to drive a turbine generator. At Chernobyl, the reactor consists of a large block of graphite with holes containing tubes of field rods inside of them. That water flows through to remove the heat. In a U.S. plant, should there be water loss, the chain reaction automatically stops. At Chernobyl, if water is lost, it is bad because the moderator still remains and it requires something to be done by a person or equipment to control the reaction. Why was Chernobyl designed the way it was when the U.S. plants have distinct advantage over the Chernobyl design? The reason is because Chernobyl-type reactors are designed to produce plutonium for nuclear bombs, while they generate electricity. Note that the Chernobyl accident occurred during the Cold War era. Short-term impact. 2 people died the night of the accident, and 28 people died within a few weeks of the accident. Most of the serious effects were due to beta rays irradiating their skin. That could have been prevented had they worn protective clothing like the ones in the U.S. plants. The exposures to the general public due to the plume range from 3.3 rem to 50 rem. Note, the most exposed city, which received 50 rem, had an increased death risk of 4%. No other country received an exposure higher than 1/4 of that due to the natural radiation during the time of the occurrence of Chernobyl. A long-term safe confinement is currently under construction to better contain radiation on a long-term basis. Since the accident, no nuclear plants have been licensed in the U.S. The viewpoint of the nuclear power by the general public has been negatively impacted for many years. One small pellet of uranium is equivalent to 1,780 pounds of coal, 149 gallons of oil, and 157 gallons of regular gas. One nuclear plant can produce enough safe, low-cost electricity to serve the needs to a city with a population of 750,000. Along with coal and other diverse energy sources such as solar, hydro, and wind energy, nuclear energy provides the most reliable and efficient source of clean energy and reduces our dependence on foreign oil. Nuclear fuel has plentiful because it takes so little to do so much.